Hey, welcome back to your favorite trig class. Let's continue on here. Let's solve this trig equation using a calculator. So we have the tangent of theta is -2. Notice your theta's got to be less than 2 pi greater than or equals 0. So let's think about this for a minute. If we have two spots where this occurs, where the sine over the cosine would be negative, right? We'd be into um, the second quadrant, where the sine over the cosine is negative, right? We have a negative value and a positive sign, right? So sine over cosine would be positive over negative would be a negative. And then the other one would be here in the fourth quadrant. So it would be that angle where you have a positive cosine, negative sine on the unit circle there. Okay? Now, this one is saying the tangent of theta, though, is -2. So what we're going to do to solve this is we're going to use a combination of our graphing calculator and our intelligence, of course. And so what we're going to do is we're going to take the arctangent of both sides and really think about this. So if I run the arctangent here, so the arctangent, goodness, arctangent. So theta is the arctangent of -2. Punch that in, and that gives -1.107148718. Anyways, this keeps going. So approximately -1.107. Okay. Now, when I ran the arctangent, remember when we took the tangent and in order to make it 1 to 1, we had to cut off the tangent between negative pi halves and pi halves. So when we take that arctangent, it's spitting out a theta here that's between negative pi halves and pi halves. So it's given us this angle right here, -1.107, right? That's what it's given us. It's not giving us the ones that we want, okay? Well, we know if that is theta right here, right, this one and this one's going to be the same thing. Okay, so what I'm going to do to find, let me get this different color here. To find my green theta from here to there is I'm going to go 180 degrees, I'm going to go pi minus that much right there, the 1.107. So one of these solutions is pi minus 1.107. So that ends up being 2.034. There's one theta. Okay. Now the other one is this black one we want. And so I just got to subtract 2 pi all the way around, 360 degrees, minus the 1.107. And that gives us my black theta here. So 2 pi minus 1.107. And that gives us 5.176. Okay, so those are my two in this case that are between 0 and 2 pi. Remember, 2 pi is 2 times 3.14, so it's 6.28, right? So both of these are between 0 and 6.28. Another way you could think about this also is think about y equals the tangent of x, and then y equals -2. In fact, you know what, let me pull it up with decimals maybe instead of drawing this thing. Alright, here's y equals the tangent of x. Here's y equals -2. You see, when we ran the arctangent, it gave us this theta, right? That was between negative pi halves and pi halves. That negative 1.107, right? When we ran the arctangent. But we want these ones right there. That's why we had to think about that and take pi minus the 1.107 and 2 pi minus the 1.107, right? We don't care about this one. This is too big. 8.318 is too big. So we just want the 5.176 and the 2.034, right? But again, when we ran the arctangent, it only gave us that theta between there. So we had to think about that. You have to really analyze that. You got to be smarter than your calculator, if you will. Okay? All right, 4 sine squared theta minus 1 equals 0. What we're going to do here, we have this thing equals 0. I'm going to go ahead and factor this. This is like factoring a squared minus b squared. You know, we know that factors into a minus b, a plus b. So this will factor into 2 sine theta minus 1 times 2 sine theta plus 1. Notice if I FOIL that, I'll have 2 sine theta times 2 sine theta, 4 sine squared theta, plus 2 sine theta, minus 2 sine theta, and then finally minus 1, right? And this equals 0. So again, it foils back and gets the same thing. Now we're just going to take, by the zero product property, 2 sine theta minus 1 equals 0. Oops, minus 1. So add 1, divide by 2, divide by 2. We got sine of theta equals a half. Over here, subtract 1, divide by 2, divide by 2. I got sine theta equals negative a half. So that I'm just thinking, well, where does the sine of theta equal a half? We know pi 6, right? We also know at 5 pi 6 is another spot where the sine of theta is a half. Here's another one, 5 pi 6. So we have theta being pi 6, 5 pi 6. Now we could keep going, you know, around once plus pi 6, so 13 pi 6, but this is outside our theta condition here, being less than 2 pi greater than or equal to 0. Now, where's the sine of theta equal negative a half? So we have one here on our unit circle, and we got one right there, 7 pi 6 as well. So 7 pi 6, and we've also got the 11 pi 6. You know, we could go around once plus 7 pi 6. We have 19 pi 6 anyways. But again, those are too big. So here's our 4 solutions on that satisfy the conditions. All right, how about 3 cosine squared equals sine squared? Now here, you know, we have this, you know, what's this theta that will make this solvable? But the problem here is we have cosines and sines. So what we want to do is get this into, it's kind of like when we're solving in algebra, instead of dealing with x's and y's, if there was any way that we could substitute in and get it all in terms of x's or all of the equation in terms of y's, then we could just solve it in one equation. So that's what we're going to do here. We're going to make a substitution, remembering our money formula, I call it, Pythagorean identity, that sine squared plus cosine squared equals 1. And the reason that's useful is because then I can replace, I can either get it all in terms of cosine squared, so I'm going to replace sine squared. So I'm going to solve for sine squared and then make the replacement. Because if I do this, see how sine squared theta is equal to 1 minus cosine squared theta? So then I can substitute. Oh, that's what sine squared is equal to. It's equal to 1 minus cosine squared. So by substitution, 3 cosine squared theta equals sine squared, which is 1 minus cosine squared. And then we can just solve it from here. So add cosine squared. So I got 3 cosine squared plus another cosine squared. I got 4 of these cosine squareds. Divide by 4 on both sides. And just like we have x squared equals 9, right? Well, square root, square root. So we have cosine theta is plus or minus square root of 1 is 1, square root of 4 is 2. So we have 2 equations here. Cosine theta is a half. Cosine theta is negative a half. So for cosine theta being a half, we got theta could be pi thirds, it could be 5 pi thirds, it could be 7 pi thirds. Whoops, that's too big, right? If we kept going with that. Where's the cosine of theta equal negative a half? We know on our unit circle that could be a 2 pi thirds, 4 pi thirds, 8 pi thirds. Again, now we're getting too big because we got to stick between less than 2 pi greater than or equals 0. So there's our solutions, pi thirds, and I'm going to write these in order, 2 pi thirds, and then we got 4 pi thirds, and then we got 5 pi thirds. There's our 4 solutions on that, okay? All right, how about sine squared plus cosine theta equals 3? Now I'm looking at this and I'm thinking, well, if at all possible, let's substitute and make this solvable. So I'm all in terms of cosines, or I'm all in terms of sines, right? Now, again, we're going to say, well, this Pythagorean identity, this money formula just always comes in handy. And I do have a sine squared, so let's go ahead and solve for sine squared. Let's go to the side here. We're like, oh, that's right, sine squared is 1 minus cosine squared. So let's make that substitution again. So by substitution, 1 minus cosine squared theta, I still have plus cosine of theta, this equals 3. So now this is like quadratic in form, where you want to get one side equal to 0. Let's get one side equal to 0. I got negative cosine squared theta plus cosine theta equals 2. Again, let me get one side equal to 0. This is quadratic in form. So it's like negative x squared plus x equals 2. So 0 equals cosine squared theta minus cosine theta plus 2. Again, similar to 0 equals x squared minus x plus 2. Right? So, if I'm at this point, I could say, well, you know what? Let's run the old quadratic formula at this point. So usually we have x equals negative b plus or minus square root of b squared minus 4ac all over 2a, right? The old quadratic formula. Instead of x, it's cosine. Cosine of theta equals negative b. So our a is the 1, our b is the negative 1, and our c is the 2, right? So x equals negative, well, let me write the old quadratic formula first. B squared minus 4ac, 2a. So we got negative 1, right? Our b is negative 1 in front of that cosine coefficient there. Plus minus square root negative 1 squared minus 4 times a times c is 2. This is all over 2 times a. So I got 1 plus or minus the square root of 1 minus a, so I got negative 7 under there. So I have the cosine of theta is 1 plus minus. Well, this is a square root of a negative number. I got a complex number here, right? This is a complex imaginary number. Well, the cosine of theta cannot be a complex number here, so we just throw this out and we say no solution. No solution on this thing. Or you can say the empty set. The empty set or the null set. Okay? So no solution. All right, how about this one? 5 sine x plus x equals 3. Now this one, you really have to, you must use a graphing utility on this. So I'm going to pause, and before I do that, what I'm thinking about is I'm going to graph this, and I'm going to graph the other side, and I'm going to see where they're equal. In other words, where's their intersection? Where's their intersection? So 5 sine x, let's see here. So, and then my other one was y equals 3. And I'm looking at this, I'm like, oh, perfect. Okay, where are these equal to each other? In other words, where's the intersection? Boom, right here. So at an x value of 0.519 and x value of 3.177 and at an x value of 5.71. That's where 5 sine x plus x equals 3. All right, I'm looking for those x values that makes that true. And here it is with like a TI-84, Texas Instruments, rounded to 2 decimal places. Well, thank you so much for watching and taking notes. We will see you guys next time.